All right, everyone. Hope things are going okay. I want to do a video about piecewise functions because I understand that these can be a little bit confusing at first, but the big problem with these is that understanding what you're dealing with, like your functions. So a piecewise function, it says that I have one function with sub functions into it. And so you can have to kind of think about a function again and what a function is. So a function is, what for every input. So you got input and you got an output. So for every input, you get one and only one output. So F1, you can't get the same Y. For F1, when you push F1 on a machine, you can't get the same output two times. So that's kind of the definition of a function. So we're not going to stress too much of this, but let's go ahead and go through a piecewise function here. So down on here is that you have these two functions. One, this is part of the function, okay? And this has a restriction. This is called a restriction. So let's look at this first part here. We got to know our graphs because our graphs really tell a lot. So this is technically, if you think about it, y equals that. So this is x plus 5. Now remember that there's a 1 right there. And remember, this is also like a slope. So this is like 1 over 1. So we're going to follow like you graph a line. So 1, you're going to start here at 5. So over here on the graph, remember you have your x and you have f of x, which is also called y if you want to do it that way. So the first thing we're going to do is that we're going to take our first sub function and go 5. So we're going to go 1, 2, 3, 4, 5. We're going to start there. I'm going to try to do these very lightly, and it's probably not going to work. So I'm going to do these in pencil because I might want to erase them because I don't want to have the whole thing. So I'm going to go up to 5, and I'm going to kind of lightly put a dot there because that's where I want to start, right? When you graph slope, y equals mx plus b. Remember, y equals mxb, right? So when you're doing this, you're going to think about, okay, if I go up 5, now I'm going to go to my slope. It's up 1, or up 1 over 1, up 1 over 1, up 1 over 1. Then I'm going to take my straight edge, my ruler, and I'm going to kind of just do this to it. I'm going to kind of lightly draw my line because I want to erase some of this stuff. Now, here comes the function. The function says I have this straight line, but look at my restriction. These are called restrict. So I'm going to restrict. And my restriction is less than 5, less than -2. So remember, the alligator, if you want to call it that, this is less than. And it's also going to be an open circle because there's no equal sign. Remember, if there's an equal sign, less than, that means you're going to go solid. That means I can include that answer, right? It's like saying 5 is less than 5 or equal to 5. So here we go. So we're going to start over here and we're going to say x is less than -2. So what I'm going to do is that I'm going to go down on the x-axis. See the x-axis here? I'm going to go down on the x-axis at -2. What I'm going to do now is I'm going to go up to my function. I'm going to go up to my function and I'm going to hit right there. Now, since that this is an open circle, I'm just going to go -2 all the way up to the actual function, and I'm going to go ahead and put an open circle. The reason I put an open circle again, because of this right here. I can never get there. It's open because of the alligator that doesn't have an equal sign. So now I have to pick, do I go down here or do I go up here? Well, one, this is less than. Well, what is less than? What is less than -2? -3, -4, -5, -6. That means all of this right here is everything that's less than -2 on this graph. Anything above this graph violates this restriction. So I'm just going to take my pencil eraser and I'm just going to go ahead and do that. So there you go. So that's the first part of the graph. Now I'm going to take a different color. Actually, I'm just going to do it in pencil before I do it. And then I kind of want to do this. Well, what's the next one? Well, the next one says I have this. But what is that? Remember, this is a function within a function. It's a subfunction. So technically, this is going to be f of x equals -4. Or y equals -4. That's what that means. That means that this is going to be a horizontal asymptote. It's going to be a horizontal asymptote on -4. So you got, like I said, you got to know your graphs. So here we go. We're going to go all the way to this part right there, and we're going to go to -4. 1, 2, 3, 4. So there's 4. And then what I'm going to do is kind of draw a line like this because it's horizontal. Remember, this is a horizontal slope. Okay, if you don't quite get this, think of the slope as 0. And you're just using, and this is just like a b. This is like the b part, and the y equals mx plus b. It goes back to those days of graphing lines and all that good stuff here. So this is what it is. Now we have to be careful. Is this solid or hollow? Well, it has an equal sign, so it's going to be solid. So here's what we're going to do. We're going to go all the way to -2. So we're going to go all the way to -2 on the x. And then we're going to go down, down, all the way to the graph. And we're going to make this thing solid. We're going to make this thing solid just like that. Now, are we going to go to the left or we're going to go to the right? Look right there. That is, looks like greater than or equal. That's greater than. That's greater than or equal. So it's going to be solid. -2. So what's greater than -2? Well, -1, 0, 1, 2. So it looks like all this is going to be greater than -2. So there's your two graphs. These are these two graphs. Now, here's kind of what the whole point of this is. One is like, well, what if I was going to pick a number? So let's say, for example, let's say on this function, I wanted to plug in 0. What if I wanted to plug in 0 to my function? So I'm over here, and I'm going to plug in 0 for x. What function do I use? Okay, you're gonna look for that right here. Do you see that right there? Or go down here. So you can look for it here, or you can look for it here, because you're gonna plug in 0. You're gonna plug in 0 for x. So x is 0. It looks like I'm going to not use this one. I'm going to use this one because this one exists on that line. So at 0, what's my output? My output is going to be -4. So at 0, that's my output. Well, let's try this again. What if you put 1? What if you put 1? Well, here's 1 on the x. What graph am I going to use? It's the same thing again, -4. And if I used 3, 4, 5, 6, all the way to infinity, I'm always going to use this graph here. Now, let's go back to this one over here. So I'm going to come back over here. What if I go ahead and use -10? So here's -10. What if I go f of x -10? What if I use -10? Well, what graph am I using now? Well, it looks like, oh, look at this. Whoa, this one's kind of tricky. Well, remember, these don't exist. So if you want to, you can kind of get rid of those because those don't exist because it violates this restriction. You can't have anything go this way of that function. So guess what? That's going to use this here. So that is part of this. Now you're going to go ahead and go -10. And what is -10 plus 5? You're going to say, well, do some math on your fingers, whatever. And then you have -5. So that's -5. That kind of looks like -5 if you graph it right. Yeah, that kind of almost looks like -5. Yeah, that's not too bad. Well, what happens if you put -4? So what if we put -4 instead? Well, -4 is over here for x. Well, that's about right there. Okay, so what is -4 plus 5? Well, that's -1. Okay, here's the trick. If I put in -2, so if I write here and I put in an input of -2, what do I get? Well, do you see what one you used? If I go to -2 and I go up, uh-oh, I have a hole here. This is a hole. I can't get there. You kind of think of it this way. You can't when you approach this, you're going to fall into the hole. You're never going to get to that line. So you're going to go instead of going up, you're going to say, well, I'm going to go down because I can get there. I have a solid hole. And this is the graph that you're going to use. And that kind of comes back to up here. See how this one is equal and this one is not? Well, the equal one is what you want to use because I can actually get there. So at -2, which is right there, I'm going to use this graph because this graph has a solid circle, and this graph is going to be -4. And that's kind of like the idea behind this, is that you want to make sure that you get the right graph, and also you want to make sure you graph it correctly. So let's go ahead and maybe do it in a second one here. So let's go ahead and do this one down here. Now, I understand that these are all lines, but that kind of gets the motions going. And you want to get the motions going a little bit. So again, looks like we have our function, which is 2 graphs. See how you have 2 graphs here? These are 2 lines, by the way. And how do you know they're 2 lines? Because you got to understand that you're dealing with that right there in disguise. Remember, this is like y equals. Okay, this has restrictions. Let's don't worry about these restrictions yet. Let's just graph these 2 lines and then worry about these restrictions because we have enough on our plate already. We have too much going. And as you get better at this, then you can go ahead and do that. So let's go up here. So we're going to go up 1, put a little dot. Up 1, put a little dot. Because what I want you to understand, I'm kind of zoom in here. As you go up, that's a solid dot. Now, what's the slope? Well, that's up 2. So that's up 2 over 1. Up 2 over 1. Up 2 over 1. Okay, I'm doing it very lightly because, one, I can erase some of this stuff. And then I'm going to take my straight edge and I'm going to line all these up. Line up all these up just like that. I'm going to try to do it lightly because I want to erase it. Okay, now what you can do is you can graph the other one, or what you could do is graph this and then go over here to this. This is saying x is less than 1. Remember, this is less than. And it looks like it doesn't have an equal sign. It doesn't have an equal sign, so it's going to be an open circle. So here we go. It's going to be an open circle. So at 1 here, it's going to go up to the graph, and it's going to be an open circle. And what way do I go? What way is true? Well, this is saying x is less than 1. Well, what's less than 1? 0, -1, -2, -3. Those are all less. And this up here violates this. So all of this down here is good. So you're going to take your eraser and just erase the top part. Because this up here, you cannot use because it violates this. Okay, next one. This point right here. Well, think of it this way. This is up 3. 1, 2, 3 again. Put a dot. 1, 2, 3, put a dot. I should do this in pencil because I'm going to erase some of it. So up 3, put a dot. Look at the slope. The slope says I'm going to go down 2 over 1. I'm going to go down 2 over 1. So I'm going to go from that point at 3, I'm going to go 1, 2 over 1. 1, 2 over 1. 1, 2 over 1. Then I'm going to take my ruler and I'm going to try to do my best to hit those. I think that's about right there. Very lightly, very lightly. Now, my restriction says x is greater than 1 or equal to 1. So x is greater, so 1 is greater. So greater means 2, 3, 4, 5. So go right up to here, and this is solid. And then I'm going to go this way. So what am I going to erase? I'm going to erase all this junk. So it looks like a V in a way, if you want to think about it. But it's not really a V because it's not, this is connected right here. This is connected, if you want to zoom in there. All right. That's kind of the way you do it. Now, you're probably thinking, how do I test this? Well, if I were to give you some information like f of 0 or maybe f of 1 or f of negative 1, you can find these by filling these in. So if we plug in 0, for here, what do our graphs do we use? Well, let's think about it. If I put 0 there, it looks like I'm going to use the top graph because it accepts that. So I'm going to go ahead and put 0. What is 2 times 0? 0. My output is 1. And you can almost see that right there too if you think about it. It's right there. It's 1. Okay, I'm going to plug in 1. So here's 0, here's 1. What graph am I using? I'm going to use this solid point because this is a hole. You can't get to that hole. You can get close to it, but 1 is right here. So I'm going to use this graph, which is that one right there. So you're going to go negative 2 times 1 plus 3. And then that's going to be negative 2. I think that's plus 1. Okay. Now I'm going to plug in negative 1. Well, negative 1 is over here. What graph am I using? It looks like I'm going to use this graph, which is right up there. So I'm going to go 2 times negative 1 plus 1. To do some simple math there, you got negative 2 plus 1. It looks like you have negative 1. And that's really close to that. Cool. Well, there you go. And I'm hoping that this is helping you out a little bit. Like I said, it's hard because, one, you got to know your graphs. So for a little summary on this, it's the graphs that you got to know. And a lot of the times it's y equals mx plus b. A lot of the times for lines and stuff like that. You got to know what a function is. You got to know what something like that is. You got to know your less than's or greater than's. And if they have an equal sign. Remember, if they have an equal sign, you can get there. If it doesn't have an equal sign, you can't get there. And you got to know your restrictions. So that's pretty much it. I mean, it's really not that bad. You just really need to know your graphs. And there's more to this, but we're going to take it as one step at a time. And hopefully this helps. And I will see you when I see you.